Chapter 6.6, Systems of Linear Inequalities. Part 1. We want you to be able to model, write, and graph systems of linear inequalities. Remember that inequalities are the greater than or less than symbols. So a system of linear inequalities is when you have two or more. And a solution to a system of linear inequalities is an ordered pair that will work in both. Now, because they're inequalities, there's not just one answer, there's multiple answers, and we could all have different things and still be right. Okay, so we're going to start off easy. They're going to ask us, is 5,3 a solution to the system of inequalities below? In order to tell that, we just need to plug in our x and our y. So remember that 5 is x, 3 is y. So I'm going to start with this first one. I'm going to plug the 3 in for y, the 5 in for x, and solve it. 3 is less than or equal to negative 10 minus 10, so 3 is less than or equal to negative 20. Because that is not true, that means it doesn't work for one, so it can't work for both. So automatically this one is no. That one is not a solution. All right, then they're going to switch it up and they're going to have us graph these. Remember that the symbols, the greater than and the less than symbols that do not have the equal to bar, those are a dotted line. And if they do have the equal to bar underneath, those would be a solid line. Okay, also remember that we are actually shading wherever the y is. So if I have a y is less than x plus 2, because this y is on the smaller, the less than side, I would shade everything below that line. If it were on the greater than side, the open side, that would be everything above the line. And we'll practice them so that you understand. All right, the easiest way to graph these is if they are in slope-intercept form. This first equation is, or inequality is in slope-intercept form. So I know that I can put a dot at the 5 since that's my y-intercept. Right there. And then I can use my slope to count down one to the right one. And I'm going to do that all the way across the graph so that I have a full line. And finish it in both directions. Okay, because that inequality has an equal to symbol, I'm going to make a solid line right through all those dots. Okay, and we actually should probably have arrows on both ends because it continues forever. Okay, then the next thing I have to figure out is where I'm shading. Remember we just talked about the y is on the greater than side of this, so I need to shade above the line, which in this case is up here. Okay, and you can always check to see if you're right by choosing a point on the graph. If you plug that point in and it works in your inequality, then that should be shaded. If it doesn't work, it shouldn't be shaded. All right, the next one, I want to get the y by itself. So I'm actually going to add 3x. Make that smaller. Add 3x to both sides, which leaves me with y is less than or equal to 3x minus 4. So now I know that I'm going to put my first point at the negative 4 and use the slope of 3, 1, up 3 over 1 to finish my line. Okay, and that one also has the equal to bar, so that one should be a solid line. Okay, and this time my y is on the smaller side, the less than side, so I need to shade below that line. Let's choose a different color so we can see the difference. Okay, if you notice, I had a pink highlighter, and where it was already shaded green is now turning black because that's double shaded. So that means as a solution to this system, anywhere in this black region would be a solution. All of this. I should be able to pick any ordered pair in that solution and it would, or in that area, and it would be a solution to this system. Okay, let's try it again on this one. The first ordered pair, the first inequality is already written in slope-intercept form. So I'm going to put my first point at -2 and use the slope 3/1 to finish my line. That one does not have an equal to bar, so I'm going to make that line dotted. Okay, and the y is on the open side, the greater than side, so I'm going to shade everything greater than or above that line. Okay, the second one I need to get in the right order. I need to get the y by itself, so I'm actually going to add x to both sides, which would leave me with 2y is less than or equal to x plus 6. And I'm going to divide by 2, so I have y is less than or equal to 1/2 x plus 3. Okay, so I'm going to start with my line at 3 on the y-axis, and my slope is up 1/2. And that line will be solid because it does have an equal to bar. And because the y is on the less than side, I'm going to shade below, everything below that line. Okay, as you can see, we have these double shaded region right here where my solutions are. You should be able to pick a point. Now there won't be a solution on the red line because that's dotted, which means that you can't be equal to that, but you could have a solution on the blue line and then anywhere else in that dark blue shaded area. All right, let's do one more for practice. Okay, this second one down here is already in slope-intercept form, so we're going to start at -2 and use the slope up 4/1. With a dotted line because it does not have the equal to bar. And that one is on the smaller side, so we're going to shade below. Okay. The top one, we need to get y by itself, so we're going to divide by this -3. And if you remember, anytime that we multiply or divide by a negative number, we have to flip the sign, the inequality symbol. So now instead of having y is greater than, I have y is less than a -2 minus 3, -2x. Okay, so I'm going to start at -3. And I'm going to go down 2 to the right 1. And that one is going to be a dotted line as well. And that one is now shaded below. Okay, that one's not showing our overlap quite as well, but we can see, because we know where we shaded for the yellow, that our overlapped section is right down here. Those would be our solutions. All right, that's the end of part 1. Come on back for part 2 when you're ready.